Hello, my name's Darren Holmes, and today we're going to be using the Primer Trainer to look at lesson number 3, loading registers and transferring data between registers. So looking at lesson number 3, you can see we have a lot of new instructions to cover. We have the move immediate instruction, the exchange, the move. So referring to page 758 of your textbook, the MVI, or move immediate 8-bit instruction. It gives a description here that says the 8-bit data are stored in the destination register or memory. If the operand is a memory location, it is specified by the contents of the HL register. Now you'll notice that it's a 2-byte instruction. It requires 2 machine cycles and 7 T-states. So we're going to be moving 8 bits of data into one of these registers, and depending on which register we want to move the data into, we have a different opcode. So on page 774 of your textbook, we can see the XCHG command is exchange H and L with D and E. So we're exchanging the 2 register pairs. You can see that there's only one hex code for it. It's a 1-byte instruction and it takes 4 T-states. Referring to page 757 of your textbook, you can see the MOV, or move, copy from source to destination. So it's 1 byte in size. It takes 1 machine cycle and 4 T-states. You notice it says for the hex code, see the table below. So looking at the table below, you can see we have destination locations down one side of our table and source locations across the top. So depending on where we want to move things from, we're going to have a different opcode. So in our case, we want to move B into A. So B is the source location, A is the destination location, so the opcode is 78. In the second instruction, we want to move C into B, so C into B, the opcode is 41. And the last instruction that we're going to be looking at is the RST, or Restart 7 instruction, with the opcode FF. It says the address following the Restart 7 instruction is pushed on the stack, and then the instructions starting at address 0038 are executed. Now 0038 is part of the monitor operating system, so I'm going to show you where that is in the listing. So this is the Primer operating system version 2.7 listing. And if you go down to line 80, you can see it's address 0038, and the instruction is C33241. And you can see here in the assembly listing, it's a jump, and it's when Restart 7, it jumps to the monitor operating system. The last command we're going to be looking at is the RST, or Restart instruction. We're going to be using the Restart 7, and you can see that its code is FF. So if you've been wondering where those opcodes are coming from, I just want to show you page 39 of your textbook. It's section 2.3.2, where it talks about opcode format. And you notice that there is a code for registers. So you notice the B register has a code of 000, and the C has a code of 001, and A has a code of 111. So looking at page 41 of your textbook, when we look at the move instruction, you can see it's made up of 01 plus the 3 digits from destination and 3 digits from source. So once again, I'm going to refer you to the Intel MCS-8085 Family User's Manual. And if you take a look at Chapter 5, it talks about the instruction set for the 8085. It covers what the instruction set is. And in here you can see it has destination and source. And it talks about those bit patterns for the register. So the register name is A, and the bit pattern is 111. And on the next page, section 5.3, instruction and data formats, you can see they talk about a single byte instruction being just the opcode, a 2-byte instruction being an opcode and data, or an address, as we saw with the in and out commands. A 3-byte instruction consists of the opcode and either 16-bit data or an address, like we saw with the jump instruction back to FF01. So in section 5.6, it talks about the instruction set encyclopedia. And for section 5.6.1, that's the data transfer group. And that group, it says the condition flags are not affected by any instruction in this group. So we're not actually covering flag registers in this lesson. And luckily, all these instructions do not affect any of the flags. So you can see that we are going to be using the MOV instruction, or move register instruction. And you can see R2 is being moved into R1. So the content of register R2 is moved to register R1. And the opcode for it is 01, followed by the 3-digit destination code and the 3-digit source code. For the MVI, or move immediate instruction, we can see byte number 2 of the instruction is moved into the register. So its opcode is made up of 00, followed by the destination code, followed by 110. When looking at the exchange command, it exchanges H and L with D and E. So you can see here the contents of the register H and L are exchanged with the contents of register D and E. And looking at the opcode for it, you can see it's 1110, which is E, followed by 1011, which is B. The last command that we're looking at is RST, which stands for restart, and it's followed by a number. And here it says control is transferred to the instruction whose address is 8 times the content of NNN. So when we look at the formation of this opcode, you can see it's 11 followed by number, number, number. In this case, it's 7 because we're doing a restart 7, followed by 111. So the command ends up being FF. Now, NNN being 111 is equal to the number 7. So if we take 8 times 111, or 8 times 7, that's equal to 56 in the decimal world. And it's equal to 38 in the hexadecimal world. So as I showed you earlier, 0038 is a memory location in the EEPROM, which houses the monitor operating system. And from there, we do a jump, because this is the breakpoint entry. So when we get a restart 7, a software breakpoint, we jump to the monitor operating system. So under new instructions, where they talk about the restart 7 instruction, and they give you an address like 0038, you should always question where that comes from, and there will be a specific answer for that. So I'd like to show you where you can get your own copy of the Intel 8085 Family User's Manual. You can go to Google and do a search on Intel 8085 Family User's Manual PDF. And one of the first items that should show up is a website called archive.org. You'll notice the manual comes up. It's 414 pages in length, and you can flip through each of these pages. You can also scroll down, and you'll notice that there are some download options. One of the options is for PDF, and you'll notice that you're able to open it with Adobe Acrobat or save the file to your USB drive. While you're at archive.org, I suggest you do a search for 8085, and scrolling down your search results, you'll notice one of the items is a pocket guide for assembly language for the 8085. Selecting it, you can see it's 81 pages in size, and as you flip through it, you can see it has all the reference materials for the 8085 as well as the instruction sets. Scrolling down, it has the download options, and you can download it as a PDF. So you can either open it with Adobe Acrobat or save the file. I would recommend that you save this one on your phone so that when you're creating your own programs for the Primer Trainer, you have a handy reference right on your phone. So using the Move Immediate instruction as an example, filling in the first 2 digits as 00, the next 3 digits as the destination, and the last 3 digits as 110, you can see that we come up with each of these opcodes. And you can see, looking at our 2 move instructions that we're going to be using today, if we substitute A for our destination and B for our source, we come up with the 7-8 opcode. And in the second case, if our destination is B and our source is C, we come up with the 4-1 opcode. So looking at lesson number 3, you can see they've given us the assembler program, and we're to start the program at FF01. And you can see they've converted the assembler program down into the opcodes that we need to enter into the Primer Trainer. So it tells us to enter the program into memory and then press the reset button, which will change the program counter to FF01. So I hope you've completed lesson number 1 and lesson number 2 and know how to enter a program into memory. So what I'm going to do is just turn on my Primer Trainer, and it's going to automatically come up at FF01, and you'll notice this is the first line of code from our previous program. So now they want us to enter in the new program. So I'm just going to enter in 3E increment 01 increment 06 02 0E 03 16 04 1E 05 26 06 2E 2E 07 E B E B 7 8 4 1 and FF. And we should now be at FF14. So now I'm going to use the decrement key to back up and make sure that I have entered the code correctly. Now at FF09, that should have been 1E. So I'm going to correct it. 1E, enter. So FF09 is indeed 1E. So you can see you can make errors typing it in. Sometimes the keys stick. So it is important to go back and double check and make sure that you have put the programming correctly. So once you've entered your program, they want you to press the reset key. They say that takes you back to FF01. And it says, if you examine the registers, you will see that pressing the reset button clears them to 0. So I'm going to check my registers. I'm going to go to function AF registers. They are 0. Function BC, function DE, function HL. You can see that they've all been reset to 0, 0. Continuing on with the lesson, we're going to see that to examine this program, we're going to be using a breakpoint. Now a breakpoint is an address in memory where you desire the program to stop or break and return to the data entry mode. So because our program is going to be moving instructions from one register to another and then exchanging them at the end, we'll want to stop halfway through and check and make sure that it is doing what we thought it was going to be doing. So looking at our code, you can see that we're going to be moving 1 into the A register, 2 into the B, 3 into C, 4 into D, 5 into E, and 6 into H, and 7 into L. Then we're going to come down here and hit the exchange command. Now this is going to exchange the data in registers D with H and whatever is within E and L. And then we're going to change them back again. So it makes sense to put a breakpoint somewhere around here so that we can see if this is actually working. So we're going to set a breakpoint at FF0F, so it should break before it does the first exchange. So we should see these numbers in these registers. So what we're going to do is at FF01, we're going to set our breakpoint at FF0F. We're going to run our program and it should stop at FF0F. We're going to examine the registers. Then we're going to single step for the first exchange, check the registers, single step for the second exchange, and check the registers. Then we're going to single step the move B into A, and then we're going to do a single step for C into B, and then we should end the program. So it says here the last instruction in the machine language program is FF, which is a restart 7 instruction. So the primer's ROM has instructions at address 003H, which return control of the microprocessor to the MOS, which is the monitor operating system. So we'll see how this plays out on our primer trainer. So with the program loaded into the primer trainer at FF01, we're going to set the breakpoint. To do that, we press function, and on here there should be something labeled BP. So that's the 8 key. So we want to set a breakpoint at FF0F. Remember, you have to press enter to store it. So it brings us back to FF01. So we're now going to press function, run, and you'll notice it stops at FF0F. So we now want to check our registers. So I go function A, that's what's in the AF register pair. The A register has the 1 in it that we loaded. Checking the B, C register pairs, we can see we have 2 and 3. DE has 4 and 5. And HL has 6 and 7. Pressing the Enter key takes us back to FF0F. Now we're going to do a single step, so don't press function, just press the step key. And then we're going to check DE again, so function DE now has 6 and 7, and then checking H and L, it has 4 and 5. So you can see it switched DE with HL and HL with DE. So pressing Enter, we're at FF10. If we press a single step again, and then check our register pairs, DE now has 4 and 5 that we had originally put in, and H and L has 6 and 7 that we originally put in. So we can press the Enter key to bring us back to FF11. So now we're going to single step, and this is the move instruction where B will be placed into A. So press the step button. Now we're going to do a function A, and you can see that 2 got placed into A, and we're going to go to function BC, and notice that 2 is still in B. So the contents of B got put into A, and the contents of B stayed the same. Pressing Enter takes us to FF12. So we're going to hit the step button again, and this should move C into B. So checking A, it has 2 that was in B, and checking the BC register pair, you can see that B has the 3 that was in C. Pressing Enter brings us back to FF13, and this is the end of the program. If I try and step it, you'll notice it just stops right there. So the program is constantly bringing us back to the monitor operating system. So the last thing they want us to do is hit the reset button, and it brings us back to FF01, and we're going to run the program. So we do a function run, and it runs the entire program all the way up to FF13 because the breakpoint is no longer set. So if I check the registers, A has the 2 in it, and B and C both have the 3 in it as before. But by putting the breakpoint in there, we've actually checked and make sure that a program is actually doing what we'd asked it to do. So the last thing we want to do is check out our simulator and see if it is indeed working, just like our original primer trainer. Now I've gone ahead and entered the program into the simulator. So I'm going to start by hitting reset. I'm going to go to function, breakpoint, and I'm going to put in the breakpoint FF0F, and we have to press enter. So now I'm back at FF01. I'm going to press function run, and then I'm going to see that it did stop at FF0F. I'm going to check my registers. So the A register has 1. B and C has 2 and 3. D and E has 4 and 5. And H and L has 6 and 7. I'm going to do my single step, and it'll do the first exchange. So I'm going to check DE, now has 6 and 7, and H and L has 4 and 5. I'm going to do my next step. DE is back to 4 and 5, and H and L is back at 6 and 7. I'm going to do my next step. So B should be copied to A. So checking A, I now have 2. Checking B, I still have 2. I'm going to do my next step. A still has the 2. And C's 3 has now moved into the B register. I do my next step, and it is indeed stuck at FF13. I'm going to do one more thing. I'm going to hit reset, and I'm going to check my registers. A was reset to 0. B and C, 0. D and E, 0. H and L, 0. One last thing I want to do is I want to check out location 0038. So if I go to Function and press Program Counter and load it with 0038 and say Enter, you can see that it is the C3 instruction. Incidentally, if you try and change a location in EEPROM, I'll try and change it to 00, press increment, and then decrement back, you'll notice it does not change any data in the EEPROM. You can only change data in RAM. Now there's one last thing I'd like to show you. If you go up to View and click on Register Contents, it'll bring up a little Register Contents window. Just place it to the side of your 7-segment displays, and this will show you what's going on each of the registers. So if you hit Reset, you can see the registers are indeed 00. And if you single step through your program, you'll notice 1 got loaded into the A register, 2 is in the B register, 3 is in C, 4 is in D, 5 is in E, 6 is in H, and 7 is in L. Now you can see that DE got switched with H and L, and DE got switched back with H and L. You can see 2 got moved into the A register. Now 3 got moved into the B register. When I go and hit the reset button, you can see all the registers are cleared to 0. This is a really neat function of the Primer simulator that's not available to you on the original Primer Trainer. So once you've completed a lesson, I want to remind you that sometimes it's important to go back and read over the lab and see if you've missed any important points. We need to remember that Breakpoint is not a register within the 8085 microprocessor. It's just a function supported by the MOS, which is the Monitor Operating System. So now that we've completed the lesson, we can go over this fairly long paragraph that we kind of skipped over, and we can have a better understanding of what's going on. So they're saying when the user specifies a break address, the Monitor Operating System replaces the opcode at this address with the restart 7 FF instruction. It then says when the user's program reaches the breakpoint. Now this is important because it has to reach that breakpoint. The Restart 7 instruction returns control to the monitor operating system. The MOS program then restores the opcode that was replaced by the Restart 7 instruction. The MOS program only allows the use of one breakpoint at a time, and this is automatically reset to 0000 after the breakpoint has been encountered. Now it says the user can hand insert breakpoints by placing the Restart 7 instruction at strategic locations throughout the user's program. But remember that any hand-inserted breakpoints must also be removed by hand when they are no longer needed. So I'm going to give you a little demonstration of this to show you what they're saying in this paragraph because it is very important. So using the provided code, we're going to use the monitor operating system to insert a breakpoint at FF0F, and the command at that line is EB. So the monitor operating system should put in an FF at that location, and then when it actually does a run, it should replace it. So we're going to see how that works. And the other thing we want to do is insert a break by ourselves so that after one is loaded into the A register, we get a break. So we're going to put a manual break in. So instead of 06, we're going to put in FF. And then we have to remember to replace the FF with 06 afterwards. So I've loaded the code for lesson 3 into the primer trainer, and I'm just going to skip ahead to FF03, and instead of 06 I'm going to put in FF and press enter. So that's my manual breakpoint at FF03. Now I just want to skip ahead to FF0F, and you can see that EB, or the exchange command, is indeed in there. Now I'm going to hit the reset button to take us back to FF01, and I'm going to press function breakpoint, and I want to put that breakpoint in at FF0F and press enter. Now from here I'm going to do a function run, and you can see that it does stop at FF03 where I put in that manual break. If I press function A, you can see that 1 got moved into the A register. So at FF03 I want to put back in the 06. So that was our original code. Now I just want to show you what FF0F contains. Okay, so FF0F contains the breakpoint inserted by the monitor operating system. And if I press function breakpoint, you can see the breakpoint is still at FF0F. So I'm going to decrement back to FF03, where the program had stopped at the first manually inserted breakpoint, and I'm going to press function run. And you notice it does break at the FF0F, but the monitor operating system does not put EB back into FF0F where it belongs. So what has happened is, when we press function run, the monitor operating system stores the data from the breakpoint, and in this case it was already FF. And then when it hits the breakpoint, it restores the data into the breakpoint, and that data was FF. So we can't have more than one breakpoint set up at a time, or we'll have to manually go in and change it back to what it was supposed to be. So I just wanted to show you the importance of going back after you've completed a lesson and reading through it to see if you've missed any key points, because some of these will come back and haunt you later when you're writing your own code. And incidentally, we've now done a update to the primer simulator. We're now on version 1.1 to accommodate this particular error, because when you write a simulator you want it to simulate the errors as well as the proper operation. So from now on we should be using version 1.1 of psim. So this concludes lesson number 3. In lesson number 4, we're going to be looking at 8-bit addition, so please subscribe so that you don't miss any of our lessons.